Thanks again, Bill, and the React Chicago group. Happy to meet everyone here. Today, we're going to show you a little bit how we use React at Kalderos and also Microsoft Azure and microservices and DevOps. And we also have a section where we're talking about how the engineering team works with our design team, how we kind of work with them to take their designs and put them into practice. And again, we hope this presentation will show you a little bit more about some of the React things that we do and probably others do as well, as far as Azure and Kalderos in general. And as Bill said, feel free to be interactive. You can ask questions along the way. It doesn't have to be at the very end. So I'm going to give the presentation overview. Dave, our co-founder and CTO, is going to kind of give an intro to Kalderos, and then Sean and John are going to take it from there from the demo aspect. So Dave.
Thanks, Mike. And thanks, Bill, for having us. Thanks to the group, and Mike, thanks for coordinating, and especially for allowing us to talk a little bit about Kalderos. As Mike mentioned, I'm the CTO, but in real life, I'm just a tech nerd. I really enjoy technology, and being part of this company for the past 5 years has allowed me to explore all manner of technology solutions, especially as it relates to the cloud. So that's been exciting. That blurb up top kind of describes what we are. We're kind of a hard company to describe, I guess. The elevator pitch is difficult for what we do because of the complexities that we deal with in the industry. But suffice it to say that if you know anything about healthcare in America, you know it's complicated, and that's true also of pharmacy, so drug interactions. It's very complicated. It's been going on for a long time. There are old laws and old procedures and old processes and old computers involved. And so what we're looking to do is clean that up, and along the way provide transparency and trust to the people who are in that marketplace. Drug manufacturers, pharmacies that are dispensing, but the key is that the most important people are the patients. And I always tell people, either you are, or you know someone, or you're going to be a patient someday. And so what better interest could you have than to solve problems for people? We are, as I mentioned, our 5th year. March of 2016 was when we started the company. And we have definitely a base in Chicago, but also a Brookfield office. We are, I think, in our 5th year on our 4th WeWork, due to our growth, and that's been exciting to see. We completed a Series B round last year with Bain Capital Ventures, and before that with Mercado, who've given us the opportunity to take the small germ of the idea of Kalderos and grow it to the platform that we envision to do all those things that I mentioned above. We live the qualities on that third line day in and day out. Pretty much every meeting we have, we review them so that people remember them and can anchor to them. And I think it really informs the way we work with each other, and the way we do our development. Certainly, and this inspired is exactly that, right? We're looking for better things to do. We're looking to bring each other along as a team. We want to be steadfast. Nothing is going to be too hard. As you can imagine, reinventing how the pharmaceutical workspace marketplace works can be complicated. And then we're also collaborative. So team. We're also an agile, flat, and cloud company. So we use agile processes and procedures. We're flat in that there's not much room between the top of the company and the bottom of the company. And we're also entirely in the cloud. And then lastly, that's the kind of things we do. We do web and API development, data engineering, data science, security, and tech and DevOps. Next slide. So we also have a few openings available. So just throwing this out, you can reach Mike Ty or Dita Vogel at Kalderos.com if you have any interest in these. We're always looking for good people, particularly full stack engineers who do React, Redux, C# and .NET on the back end. We have openings for data engineers, particularly with experience in back-end development and APIs. And then lastly, a tech ops engineer. So happy to share the details of this at the end if you want to talk. But otherwise, next slide. And yeah, so what makes Kalderos a great place to work, aside from the things that I mentioned previously, we are a best place to work for built-in Chicago, second year in a row. We have really good engagement with built-in and have gotten a lot of great candidates. We have a number of perks. Fair PTO means we don't count your days off. We ask that you take a minimum, but there's no upper limit. Flexible schedule. Everybody's got a life, and we work our lives. We live our lives around our work. We have a 401k, healthcare benefits, and all the other things that you can see there. It's actually a pretty fun place, pretty family-oriented place to work. And then what's great about the engineering team? Sorry, I can't see that one. So we have 20 plus engineers. They're all, what's interesting about them is that they generally all started at the same time. They were all new to the company and they coalesced as a team when they did that. Actually, the two people presenting tonight are our first two development hires. So they've been around since day one, but they were brand new to the company at the same time. We're solving cutting edge problems using cutting edge technologies. As I mentioned, we're entirely in the cloud. We value diversity and have a group dedicated to that, not only in our hiring, but a group dedicated to that as far as it being part of our culture. We have an education stipend so that you continue learning. We expect that of people to continue learning, and we look for the people who want to do that anyway, who make that part of their day-to-day approach to work. And then lastly, the working on vibrant teams. We're product focused so that people align behind a product as opposed to a technology. So developers are working with designers who are working with PAs who are working with product managers. And it's really a fun, compelling thing to do. Next slide. Yeah, and now without further ado, we'll pass it off to Sean and John, who I mentioned are our earliest employees in the technology space.
Thanks, Dave. I'll go ahead and share my screen now. Let me know when you guys can see. It should be pointing to localhost. Good. All right. So yeah, I'm running this locally so I can make some changes live, but we've got a quick demo here that just kind of shows some of the React technology that we use at Kalderos. First and foremost, we use TypeScript. I don't know if you guys are familiar with that, but it's essentially just taking any data that's going to be running through your app and giving it a type. So yeah, let me walk through the app real quick, actually. This is just gets you a list of football leagues. So not American football, but European football. So
can you make it a little bigger, please, Sean?
Yeah. Is that better?
Yeah, and then the code too.
Okay. Yeah, I'll try to make that bigger when I go back to it. But yeah, so this is the list of football teams that we have here, and then we can also search for it, search for players through the list. So I'll just kind of go through how we do this, and let me see if I can zoom in. Can you not see that at all? You know what? I think I have to share it over here. Hang on one second. Is that better?
Yeah, that's a lot better.
All right, cool. All right, so yeah, so like I was saying, TypeScript, first and foremost, you see all the files are TS instead of JS. That's one big difference that you'll see. It doesn't really mean anything different when you look at the code, but you just have to prepend that with the TypeScript. But so you have your root state of your app, and that is through, we use sagas. I guess I'm jumping ahead, but here's our root state right here. And if you go back to the types, you see how we have a teams array, a selected team, and it's all just typed out. And like the club name is a string, the number's a string, name string. It just keeps you honest while working through your app. So if you do provide the wrong prop, you'll get yelled at through your code editor. It's kind of tedious, but it's definitely worth it in the back end. It kind of saves you a lot of time and debugging. So another difference that I was talking about is, so we use Sagas as our middleware over Thunk. And the main difference between those is Sagas just kind of sits separate in itself, and Thunk is run through a bunch of asynchronous calls. So if you have a super complex app, then Sagas is probably the way to go. And let me show you how those work. So right off the bat, right when you run your project, the Sagas activate right away, and they're just watching for certain actions, and it'll take that action and run through your reducer and update your store. So let me just show you something here. So searching for a football player, here's the Saga file. It's run through a try catch block, and it calls the API call here. And if it's successful, it'll hit this success action with your response. So I'm going to mock a failure so we can see it hit this failure action right here. I'm just going to do that by changing the URL, just something nonsensical. All right, so now when we search, you see that we hit that error action, and that then updated the reducer with the error true, and then on the front end we connect that to the store and error to display any messages that you want on the UI. You can run it through logs to pick up those error messages and error logs. It's helpful for like triaging bugs when your users are using it. Many benefits to that, but another difference that we use, so we use test-driven development, and we use Jest and Enzyme. So I've written some just simple tests here. Like the loader, it's pretty self-explanatory. The loader is set to false. So when it mounts, you look for the wrapper and you expect it not to exist. And then once I change that to loading, I do expect it to exist. So let me just run the test real quick. And it also gives you a nice printout of your, it also gives you a nice printout of your test coverage, so you can see how well your application is covered. Let me see if I can hide that. Here we go. Okay, so it's taking a while for these to run. Here we go. So it gives you your file coverage percentages here, and it tells you the lines of uncovered code. So it just gives you a good whereabouts of where you could go through and make your app a little bit better with test coverage. So that helps in the long run. I've broken many tests and not realized after I've even pushed code that it could break something in the application. So this is kind of your first line of defense and looking for something like that. that's pretty much all the add-on differences that we do with React. Can't think of anything else. Yeah, I think that's about it. Any questions at all? I can't find the video right now, but I'll take that as a no. John, do you want to go in and explain the Azure Function App?
Hello, everyone. I'm John. I am a full stack dev at Kalderos. Like Dave said, I was the second developer in Chicago that was hired. So I've been there about a year and a half, and I can attest it's a pretty cool place to work. So yeah, peep those job opportunities. Okay. I am going to, so basically what we're doing with this app is instead of using a standard API, as we do for most of our products, we decided to try out an Azure function. And Azure functions are basically a service that Azure offers to, the way we use it is to basically write kind of an alternative to a standard API call. So yeah, reasons we might do that. If we have something we're trying to accomplish that might not fit into one of our standard API microservice products. I don't know, so we have different products and we have our APIs for those. Sometimes we have functions we need to write that just don't fit well in those projects. So we can instead do a kind of a microservice and build an Azure Function App, which is pretty nice that we have that capability. Another reason to use a function app over a standard API. So as you saw in our job openings, and as Dave and Mike talked about, we use a .NET C# backend. Sometimes maybe there is a solution that would fit better in JavaScript or a Python or something like that. And instead of creating a whole Python app, we can just hop into Azure and make our little function app. So I will show you what we've done. In order to pull in all of the teams for our football app that Sean was showing you, we created a function app that it's super simple. And that's the nice thing too. There's a lot of stuff going on. There's a lot of features. There's a lot of extra pieces, but at the core, it's really easy to get something spinning. And before you know it, you have a fully functional full stack app. So yeah, first thing I wanted to show was our proxy URLs. So when we set up the app, we have our backend URLs that actually point to the function apps that we have set up. In order to kind of surface those to the UI, we might want it to look a little different, a little cleaner, a little easier to read. So we can create these proxies that actually point to different pieces of our function app. So we have one here that points to the part of the app that actually gets the teams. So when Sean first loaded up that UI, it brought up the dropdown with a list of all the Premier League teams that you could choose from. So we're using this index function app to do that. As I will show you, we also have a search. So Azure has a cognitive search function that they would say works similarly to Bing, but I think everyone else would say it works similarly to Google. So when you search for something, it's got an AI capable search. So we have integrated that into this as well. So when Sean showed you the search, it was actually using an Azure cognitive search function. So yeah, we'll go ahead and dive in to the first part of this. So we've got so what this is doing is it's like the most simple possible backend service you could have. I've got an array of objects that has a Premier League football team with only 4 players on each because it took forever to enter the player information. And so yeah, this is literal just like hard-coded data that we have. And then we got the actual function that takes in the request. So this takes in the HTTP request. It searches for either a body or a query string. We're given the option to pass in a name. So in this instance would be either a team name or actually, yeah, so it'd be a team name for this one. And if we are, so yeah, it comes in, we jump up to this function. So the data it jumps up to get data, passing in the name, which either could be a string or null. In this instance, okay, so I actually have the URL here. Okay, actually, I'll show you, man, this thing. So, yeah, I just wanted to show you how to get the URL. That's it. You can get the URL and see what data you're passing back, which is nice. So you can just pop that into the browser. I didn't pass in a name, so it's giving me everything. It's giving me every team, every player. If I add a name onto the string, so let's say I didn't know the whole name, I just put in a piece. Right now, it's not gonna bring it up. It's gonna tell me what I sent, but that's just, so right now we have it where you have to actually put in the whole thing. So yeah, if you added that to the query string, there you go. And I showed you that because I wanted to show you how easy it is to update this too. So let's say I just want to look for pieces of the string. I can do, instead of looking for an exact match, index of name greater than -1, and then save it. And that really should be it. Now, if I go back to the URL and do that partial name like I did, bam, still brings it up. So yeah, it's really nice. It's super quick to save it and test. And that's, I think, one of the benefits of working with the Function app. So this is how we're populating the dropdown with the teams. We also have the search function. So I will show you that as well. Go back. So like I said, we have the proxy that points to the search function. So if I go back out, this is really nice and kind of magical. You don't have to do a whole lot. Really, all you do is, and again, there's plenty of stuff you could do that we haven't needed to with this demo, but we're focused on the indexes. So what you do is basically, as part of your URL, you are passing in an index, and this search function is going to search for that specific index. So we gave it players because that's what we're searching on. So if you click in here, it actually gives you this query string to test out the search functionality, which is cool. So you can test it out right in the Azure portal. Here's kind of where you set everything up. So it kind of looks like a like a SQL table. You add a field, and so anything that you want to search on, this is where you're going to add it. And we have, as you saw in the JSON, we have players. Each player has a kit number, a name, a position, and a club. And the nice thing is you can actually decide, all right, I don't want kit number to be searchable, or I do. So I went ahead and made everything searchable. Here, I'll pull this over. So yeah, like search kit number, it comes up with every kit number with the number 7. Or if you just search name, it'll pull up by name. So that's actually pretty great. You don't have to, choose the field you want to search. It just does it based on the settings in here. And it's really that simple. So if you want to add a field, you just click on add field, name it whatever you want, and then you kind of choose whatever type you want it to be. So for the player, I decided to make it a complex type collection. So like it says, it needs to have subfields, which are these 4 fields here. And I did that because when you set this up, if you're searching for a piece of that collection, I wanted it to bring back everything. So rather than just having the name, for example, as its own field, if I searched on that, it would bring back the name, but then you'd have to have some sort of loop to find the name and then bring back the object. So this way, it just brought back everything without having to do any sort of extra logic, which is really nice. And again, this is simple. It's kind of, to me, like pretty magical. And it's cool that they offer this, because this is really it. This is all we had to do. Set this up, and then add the proxy to our function app. And as long as you hit that URL, and we're sending where'd that go? So we're sending the search as in the body of the request. So whatever it's getting from the body, it's just taking that and searching all of those fields for whatever you pass in. I think as far as this portion goes, that was all I had, unless anyone has any questions while I'm in here.
Yeah, we have a question in the chat from Greg. I don't know if you want to read it there or.
Let me take a look. Chat. How do we get to the chat?
Hey, John, I can just read it for you.
Okay.
Greg asks, is there any kind of security outside of group that could be implemented in cognitive search, or should you proceed with indexing with the assumption that everything index is available to the client end user? And I wrote the part about, I think you can uncheck retrievable for certain columns. But then Greg said, but if you only wanted a subset of the data, are there restrictions? So restrict certain rows from coming back.
Oh, okay. So if you're saying if you're searching this player, do you want to not bring back everything that might fall under that category?
I think that was the question.
As far as I know, you would either check searchable or not. I think I'm not, again, like the setup for this was pretty simple. I haven't taken a really deep dive into this. We haven't really needed to do anything like that. But yeah, I'm sure you could.
So John, this is Greg. I'm the one that asked the question. So
Okay.
what I'm building is like a home management application that allows people to search service providers based on their location. Right.
Okay.
So like I could see all the service providers within, let's say, 2.5 miles of my home.
Mm-hmm.
But let's say, somebody else should only be able to see within 2.5 miles of their home. Right. And I want to be able to, rather than running SQL statements with in-depth where clauses, I was looking at cognitive search and trying to figure. I didn't know if Microsoft says there. Yeah, right. Microsoft says there's not. I didn't know if possibly their documentation isn't necessarily the best. So I thought maybe that if somebody had a way of applying that kind of row level security within the index, I'd ask the question. So
kind of like an extra parameter that says within a certain distance or whatever you want to do.
Right. Like basically you pass in like your user ID, which has, let's say, your home application.
Right.
It's stuff you could do right now with SQL and a
Right.
server, right? But I didn't, obviously having index columns like in a search function is much faster than running a SQL query.
Yeah.
Could you control that from the function and then make the actual proxy endpoint inaccessible to anything but the function?
That's kind of what I was thinking is, it might work outside of kind of what you're doing within that actual search function. So maybe you have an index for specific users, or I don't know. That's a great question, though. I think that.
So Dave, what you're suggesting is almost like what I was thinking of, basically passing it to my server to run the logic, and then the server passing it to the search index, as opposed to the React client passing it directly to the search index.
Right. Because you can secure the Azure function either with at the function level with a token, or you can require other permissions. And if you did it there and then just pass that on to the.
Yeah. All right. I'll look at that. 'Cause I'm running Azure B2C on the authentication piece, so that should be possible.
Okay.
Sorry to go off.
No, that's okay. That's a good question. I knew I wouldn't have the answer to everything, just because I'm not overly familiar with this, but it's good that you asked. It's because I'm curious too. So hopefully I will learn the answer to that.
Mitch looks like he has a question.
Yeah. So in practice, do you guys find yourselves editing the logic in the Azure UI? And how do you test and manage? Do you do any sort of versioning there, or what really happens?
So you can actually, and I think what would be ideal, you can develop in a text editor and then push that to the function app, which is what we typically would do. If it's going to be in .NET Core, then we would, maybe write the function app in our Visual Studio editor and then push that to the function. So it can actually then be under that version control and the testing and all of that. This example obviously is written directly into the portal. But yeah, you can write them in your editor and then push them to your function app.
Mm-hmm.
And if I could give you a little bit of that 5-year experience, Mitch, that's exactly what is great and horrible about Azure Functions, is that they're so easy. You could easily litter your entire workspace with things that you've forgotten you've written, things that it's painful, obviously, to edit in the Azure portal, but there are plenty of tools, command line tools that you can plug into VS Code and things like that John mentioned, where you can create a project locally. And then build it and deploy it, and also commit it to source, and then make that part of a pipeline later.
Yeah, I mean, I'm just curious because it's so much more accessible than Lambda or serverless or the Google Cloud version. So I'm just curious, in practice, you find yourselves actually writing it and committing it, and then like deploying multiple versions and testing against them, as opposed to just editing in line here?
I would say that was an early practice, and it's not an enterprise practice. It'll collapse under its own weight if you start doing that across teams and multiple people. It's easy when there's just one person, but yeah, if you're looking to source control and you're looking to manage code, you probably don't want to work in the portal UI.
Right. Yeah. Okay. Cool.
Yep. And yeah, I would just note that obviously most of our API lives within C#.NET Core. So most of our API calls are not using these Azure functions. It's just like specific instances where we think it might make more sense to live on its own outside of one of our API services.
And John's right, it is totally cool and fun.
Yeah, it's the Azure portal it's fun you can connect it to a database too. So that's another part of the Azure function. And we do that in at least one of ours I've worked with. I know we do it in multiple ones, but instead of just writing JSON in the function app, you can set up these connection strings. So, you know, whether it's MySQL, SQL Server, whatever you're using, you just put the name in or put the value in, give it a name, and then you can actually either hit a store procedure or actually write raw SQL into your function as well. So yeah, it's also got that ability rather than just writing hard-coded data in.
And just so everybody knows, we did a version kind of this demo before, and I asked John, who's never used Azure before, to write the function and figure out all this stuff, and he did. So part of this demo is kind of like, hey, you know, if you're a front-end developer and you need to do some back-end stuff, this is one option. And like Mitch and Dave were talking about, there are some drawbacks eventually of going too crazy. This is a pretty quick way to get up and going.
Yeah, yeah. If you're just trying to spin up a very simple app and you didn't want to create an entire backend app, then you could. I think this would be a nice way to do that too. Yeah. Any more questions about the Azure Function App? If not, then yeah, I think that's all I had to show with this portion of the demo.
Okay, John, did you want to talk about the CICD or the design tokens?
Yeah, so CICD, we also use Azure for our pipelines. I know that Sean was gonna maybe, I have it running locally too, so I can also make a change. Sean, do you want me to just go ahead and do that?
Did it.
Oh, okay.
Yep.
And we don't have, so normally when we are working on the front end or the back end or whatever we're working on, we have, you know, we check out a branch from master as is the norm, and then push it to that branch, create a pull request. One of our team members, or maybe multiple, kind of look through that to make sure everything's good to go. And then once they approve it, we go ahead and merge it into the master branch. And as soon as that happens, then normally our pipeline should just go ahead and start a build. Sean, did you merge it into master?
Sorry, yeah, I did. It's going right now.
Okay. It's going right now, or?
Yeah, it's building right now.
Okay, so yeah, I just had to refresh. So that is, so we have the automatic builds. So you can see normally, yeah.
John, you're not sharing your screen. I don't know if you...
Oh, I forgot I stopped doing that. Okay, let me go ahead and share that again.
Cool.
Okay, I will go ahead and go back here. All right, so this is all of our pipelines that are set up within this environment. So we, through, you know, our pipelines are set up through a lot of different environments, whether it's dev or tests. We have a stage environment, we have a demo environment, and then we have production environment. So once we merge that code into the master branch, like I said, then the dev environment, the pipeline will automatically start its build. And then from there, once we've tested or done whatever we'd like to do, then we can actually push that to the other environments as we desire. But here's all the pipelines we have. And this is the React.js demo. So this one's connected to that GitHub repository. And so once Sean merged that code in, this process started. You can kind of see all the steps that it goes through, which is nice. If something does happen to break, then we can go in and kind of figure out, one, it's easy to find which step it broke on. A lot of times it will be test, whether we didn't hit our code coverage or whether a test just happened to break. The NPM build naturally takes a really long time. This is always the one that you're waiting on for. That one's not too bad because we don't have that many packages. But yeah, so it goes through every single stage that it needs to. And part of this, we use SonarQube, which is kind of a linting process that steps through our app and finds anywhere that maybe the code's a little clumsy or something isn't written the way it should be, too complex or things like that. And then it'll give us a report back and we can go through and kind of learn how to be better and not get yelled at by SonarQube, which is nice. So yeah, once it steps through all of these processes, it'll, a nice thing too about this is it does give you a breakdown of your code coverage. We are a startup, so we tend to at times work super fast and we try to keep our test coverage up. But if it's not, then it'll be very obvious and we can take some time to kind of work on that. But yeah, this is still building. And normally, I mean, it can take on average around 10 minutes, maybe. Once it's done, we go into this release. This is what I was talking about earlier. We can release the code. So actually it might be done now. So yeah, once it's on dev, we can see that it looks like it is complete now. And we could go ahead and deploy it to test. We don't ever do this, nor can we, but you could deploy to prod. We don't do it in here at least. So normally, yeah, we push it to dev. You might test it yourself as a developer on that URL. And then when it's ready to be looked at by QA, then you would push that code to the test environment and it would be ready to be looked at by whoever's testing it. Sometimes if you do try to, it's still building. If you do try to, or if it doesn't automatically kick off, you can click into the pipeline and you could run the pipeline. One advantage of this too is you can run it off of different branches. So any of these, and this is good for hot fixing, if we have something that happens, something that breaks, especially in prod, you know, we might, obviously we're gonna go back to probably whatever branch we last released and fix the issue. Hopefully, you know, get it fixed that day and then go back in here, find the branch that we released off of, and then just build off of that. And then we can, you know, step through the process and eventually get that on back into production. So this, yeah, a lot of stuff in Azure I find feels cumbersome at first, but once you start using it, it's really nice. And there's a lot that they offer in all the different environments and portals. Do anyone have any questions on the CICD or anything I've shown? Okay. Were we going to jump right into then the?
Yeah, you can go into the design.
Okay. So the last thing I was going to talk about is how we, as especially front-end developers, work with our design team. We're a very design-focused company, especially working within the healthcare industry. I think a lot of the software people use is really outdated. We've kind of found that out the hard way because a lot of our clients use IE11 still. So we have to code all of our apps to work and function and look as good as they do on all the other browsers, which is not an easy feat. I would go as far as to say it's just really not fun at all. But yeah, so we are very design forward, which is, we have each team, each product has at least 1 or 2 designers that we work very closely with as front-end developers. They'll kind of work on the designs, bring it to us, and then we'll maybe talk about it, go to them with any questions we have, and then throughout the process while we're working on it, we always have a very close conversation happening. One way that we do the handoff, is by using a software called Figma. And this is kind of the sandbox for the design team. They will mock up all of their stuff in here. And when we use, so we're agile and we use Jira software and we write stories and very standard, tech shop sprint stuff. We'll get a story, we'll have the acceptance criteria. And then the nice thing is there's always a link right to the Figma file where that design lives. So we'll click on that, it'll take us in here. This is our login page for the product that I've primarily worked on. The cool thing about Figma is it shows you a lot of information. It's very interactive. So if you click on different elements, it'll show you the width, the height. This is kind of stuff we're learning as we go. Being a startup, we don't have a design system in place yet. I know that's something that we're working on and that's been on, on the table for a long time. So we're working on that, but until that gets implemented, there's a lot of back and forth and a lot of communication that needs to happen. So once the UI team gives us these designs, you pop in here, maybe like scroll your mouse around, look at the sizing of things, look at the colors, look at what components are available. If you think about this in like, what is it called? I think it's like the atomic display or atomic component method. You look at what components are here, what we might already have built. Like I said, in the future, we'll look at maybe what we have in a shared component library. But yeah, so once we figure that out and get kind of a plan on what to do, then hop in the app and start building it out. But one thing that is helpful, so over here we can actually view the CSS and other properties, and it'll have these like hex codes and font sizes and stuff like that. And that is nice, but it might differ a little bit and it might not always be super consistent. So one thing that we've done is we put together a file of design tokens. And that's just a way to keep things more consistent and not have to go back to the designer and ask a ton of questions. So what that looks like, and eventually this is also something that we'd want to live, within our design system documentation. Until that time comes, we have it just living in the app. So we've got different categories. We've got colors, we've got spacing and layout. So that kind of changes depending on where you're at on the page or if you're going vertical or horizontal. So we've just got all of these set values that have this token. So it's almost like, a JSON object where it's got a key and a value. So we don't have to go through and figure out every single place. And this has actually happened where our designers have decided, and obviously there's other people that go into making these decisions, but I've decided to change some of the coloring. And we want our primary color to now be, orange instead of dark blue. So instead of having to find every single place we use that hex code, we can just change it in one centralized location. and that'll change throughout the app. I was gonna try to show an example. I don't know if Sean, are we using these tokens? I assume so.
I'm not too sure actually.
So I think these are actually using them. But yeah, if we wanted to change the header colors and they were using, okay, so yeah, they're using this primary. So this gray darker. I don't know if anyone has experience with design tokens, but so this is what I'm doing. I'm just changing. So those headers are using gray darker. I'll just change it to the gray darker to this color. And it should update. So yeah, there you can see that both of those headers changed. I didn't have to go find the class they used. I didn't have to, search each class and find that hex color that they were using. I could just do it right there in the token, and it took care of all that. So we have different products too. So cross product, this has gotten even more important because we want everything to be consistent no matter what product it is. Yeah, another nice thing with SCSS is they have these mix-in classes. This is another good way to deal with styling. So we have a decent amount, and basically it varies based on what size we want the font to be, what font weight. So, are we dealing with a header or a label or what? And all you do with this is you take the mix-in name, add it to a class name. So if we wanted, well, here's an example. So the app label, right now it's bodyrig 03. So that has all of the styling involved with bodyrig 03. And this is a nice way to keep the CSS files or the style files a little cleaner, because I'm sure everyone who's worked on front end development knows that they can get pretty out of control. So yeah, if we wanted, to make that font smaller, we would just maybe change that from 03 to 01. And there you see it got a lot smaller. And this is just I don't know, it's helped out a lot. And if we look at these Figma files and something doesn't look as consistent as we're used to, or it's not the same color or maybe the same spacing, then we know like it's always based on a token. So we might have to go ask them if it's a pixel off or 2 pixels off. We're like, oh, that's probably the spacing medium token. And we'll just, use that and then maybe double check with them. But yeah, until we get a design system in place, that's what we're working with for now. Does anyone have any questions on tokens or classes or anything?
Okay, thanks, John. So that was our demo for today. So if anyone has any general questions, we can stick around and answer a few. Okay. Looks like everyone's good.
Yeah, thanks a lot, guys. It was great demo and great talk.
I have one small question about Azure Functions from a performance perspective.
Oh yeah, go for it. And yeah.
How do they, I'm a little familiar with AWS. How does Azure Functions charge? Is it per hit or per, I don't know, power cycle? How does that work?
You want to take this one, Dave?
Sure. There's actually a variety of ways to do that. And it's true of almost any service in Azure. And and you can pay for per consumption, so per usage. You can reserve usage. It really is all over the map. The more you use it, obviously the better discount you'll get. But typically the default is that consumption basis. And you run the risk though in consumption that if like you're familiar with web servers powering down, that first hit after a power down sequence can be pretty expensive, can take a long time for the server to spin back up. So those are some of the concerns that you need to think about.
Okay, thanks.
Okay, I think that was it, Bill.
Cool. All right. All right. Let's end it then. And thank you, everyone. And we'll see you next month. If you want to stick around, free, but we'll officially end it here.
And thanks for having us.
Yeah,
Thanks,
thank you.
everybody.
Everyone.